Before we can start coding, we have to set up a couple of things. The first thing we need is Visual Studio Code. I've put the link in the description and I trust you know how to install it. Then, and this is a decision that you have to make, I will be using the Microsoft compiler from Visual Studio Community. And therefore I need to download Visual Studio Community as well. I have it already installed, but I will show you my installation. My installation is very simple. I have clicked desktop development using C++, and down there I have used game development using C++. That is everything that I have selected. Optionally, you could use LLVM as the compiler. I will not be covering how to set up the build system using LLVM, but trust me, it is almost exactly the same. The only difference will be in the compiler flags, which we'll see later on. We will also need Git. The way this will work is that for every tutorial there will be a branch. And if you want to skip maybe 1 or 2 tutorials, you can do so. I recommend that you do them all, of course. But if you want to skip, then you will be able to clone the branch or switch to the branch and then continue from that point onward. I'll explain how this goes later. Downloading Git is very simple. You just select your OS and then this installer will pop up. You will save the file. Once it has downloaded, you will open the file and I will show you how I have set up my Git. I will not be using any of the interfaces, any UI. I use Git from the command line and I encourage you to do so as well. I will also be showing you how to do it. So basically I have unticked all of these options. This next page might seem confusing. What it tells you is that whenever you interface with Git using some special commands, Git will use what is called an editor to show you text. And it is telling you that it will use Vim as the default text editor. If you don't know what Vim is, I encourage you to use Notepad++. I know a bit about Vim, so I will keep this as default. But if you don't know what Vim is, you should probably stick to Notepad++. You have been warned. This next page is kind of a troll page. I let Git decide to name the master branch master and not main. If you don't like master, then you can name it whatever you want. Knock yourself out, right? For the rest of the options, with the exception of one, I use the default. Simply because I don't exactly know what Git is asking me to do and the default has worked for me. So yeah, that's what I'm sticking to. And I only use some very basic Git commands. If you know more, you're free to use whatever you want, but I'll be sticking to the default options here. So default option here, default option here, default option here, and here, and here. Yep, I don't use any credential manager core, blah, blah. No, this is the only exception. Yep. Nope. And then install, right? And even if you have Git already, it'll manage the installation for you. So there's nothing to worry about. Once finished, uncheck view release notes. We don't care about those. A quick check if it is working. We press the Windows button, type in cmd and type git. If that works, if it tells you all of that stuff, it should be okay. If not, you might have to restart your computer. Now, once Git is set up, we will be using it immediately because I want you to get comfortable using Git on the command line. I have set up a Git repository for the game we will be creating, and you will need this link. I've put it down in the description. Now we copy this link, create the folder anywhere you want, then go with the mouse into the path up there, click and type in cmd and enter. This will bring up the command line and we will now type in git clone and paste the link that we copied from the repository. Now, since the repository is open alright, we can see that it created a folder called Pong from scratch. This is where our game will be. And we can already do the first thing that we need. We create a new folder called source. This is where we will put most of our header and CPP files. Next, we need to create a build.bat file. The build.bat file will be our build system, and it can be difficult to create if you don't know how to do it. In case you don't have it, you need to enable file extensions. Go to the topmost right tab, which will probably be view for you, and then enable file extensions over here. If you see, when I disable it, the extension is gone. We need the extension. So we go here, we create a new text file. We call that build.bat. It's going to ask us if we want to change the extension, and we're going to say yes, please. We now need to open our project, and we can do that in two ways. If you installed Visual Studio Code and gave it the option open with code, you can do that now. If you haven't done so, inside code, you can open a folder and then select the folder that you want to open. Now, once we have set this up, we will see our source folder here, the build.batch, which is empty, license and readme. Next thing, we need to talk about extensions. We don't need many extensions. Technically, we only need the C++ extensions. So you go to the left here, you go to extensions, which is these cubes, and then you type in C++. This will probably give you the first result. Next thing I recommend, but is not required, is better comments. And maybe the shader language support, which will be very light highlighting of GLSL shaders. Once you've installed all the extensions, the next thing we need to do is actually fill this build.bat file. In order to do so, we need to locate the CL compiler that ships with Microsoft Visual Studio. You know, the one that we installed. Or you can use the LLVM compiler at this point. I will be looking for the CL compiler and I'll show you how to find it. I also have a video on how to set up a build system like this in Visual Studio Code. I'll put that up here. So if you've installed Microsoft Visual Studio, you have to find it. It is most likely under C and then in Programs x86. And there you have a folder that is called Microsoft Visual Studio. In there you have different versions. But what we are going to do is we type in vcvars. This will bring up all of these batch files, Windows batch files. And we will be creating a 64-bit application, so we will need this one. When you run this, it will set up a development environment that we can then use to build our application. And again, the linked video will have a more in-depth explanation. What we will do though is we right-click on the file, vcvars64.bat, and then open its path. Inside this path, we press Shift and then right-click, and then we copy the path. Now that we have the path copied, we can go back to Visual Studio Code and paste it. This is what we will be calling. And call in batch file means we will call this other batch file. I will be skipping over most of the batch file stuff because I think it is not that important, but I'll still mention what each line does. For example, the add echo off means that we will not be displaying any output when running this batch file unless we explicitly call echo, which we will do later. For example, we will do echo and then building main ... right? This is what we'll do. Now let's set up the build system. What I like to do is I like to organize the build system a little bit by defining variables. For example, set includes and then set links and set defines. This is the typical build stuff that you see in CMake, for example. Next, we will call the CL compiler, and we call the CL compiler by typing in CL. This will work because we called the vcvars.bat beforehand. If we remove this call, we will not be able to call CL. The first argument that we need to specify is the error handling argument, which is EH in big. This will tell the program how to handle the case when the application crashes. I don't know much about it. I just know that it is important and that it is required. If you wanna read more, I've put a link in the description. We also need to add those SC down here. Then we add the includes. Whoops. Includes. Whoops. We add the defines. Next, we need to tell CL which CPP file we want to compile. We will be compiling the source main.cpp. And last but not least, we need to the links. And that's it. That is mostly it. We also need to fill in these, but we'll do that later. This is the simple build system. Now we can go in here and under source create a new file, main.cpp. Whoops. And then we can create a very simple program. Let's include IO stream. And then int main. Return 0, not important. And what we'll do is std cout hello world. Std and line. Next, we need to tell VsCode that it should run the build.bat file as a task. And we do that by creating a task. And we create a task by defining a folder. We create a new folder in the root, which is called .vscode. In here, we can create a new file called tasks.json. This is where we will put our tasks. We then start the file by opening in curly braces. And oftentimes, you can start these files by typing version. And then auto-completing, it will most likely fill out the 2.0 for you. Then we need to define the tasks array. Oops. And inside the tasks array, we open with curly braces again. And this is where we will define our task. The first thing we need to specify is the label, which is just the name of the task. I call this Windows build. Don't forget to add the comma at the end there. And the next thing we need to specify is the command. The command will tell the task what to run. This is where we will use the first variable, which is $ curly braces open workspaceFolder. Meaning this folder right here, the workspace, the root folder. We then go ahead and call build.but. That's it. This is the command that we'll do. The next and last thing is we need a group. And if you're lucky and you do auto completion, you get this preview and you can select the default build on true and kind build. And that's it. If we now press Ctrl+Shift+B, you see that it built main.exe over here. It is Ctrl+Shift+B, and it should then show you in the terminal that it built successfully. You can then press enter to close that terminal. This is the first task that we need to do. Now we need to tell VsCode how to run our program, and we do that by defining a launch.json file. So we go back over here inside the .vscode folder, we create a new file called launch.json file. And oftentimes we start up with curly braces again, we type in version and autocomplete. Boom. The next thing is called configurations, what we need. This is again an array, and we add our first configuration, which starts with curly braces. The first thing we need to do is we give it a name. This time it's not label but name, so don't know why, but yeah, that's how it is. I would like to call this Windows Launch. Next, we tell it which program to run. And we will use the same variable again here, which is $ curly braces open workspaceFolder. Close curly brace. And then we call main.exe. Now, when you are here and you don't know what to do, what I like to do is hover over this and it's telling you, okay, so we need a type and a request. I guess we do the type first. And I know from experience that this is cpp vs debug. I don't know what that is. I just know that you need it. And that's fine by me. Again, I don't really care about VS Code. I just want to type in some C++ code, right? The next thing was the request, and this should automatically fill to launch, which makes sense. And then we also need a current working directory. This will most likely default to workspace root. I like to use workspaceFolder though. I think they're the same. I don't know why there's a difference. That's just what I like. And if I now press F5, it will run my program and print out hello world. So we have now successfully set up our development environment. What we now need to do is link against Vulkan. I've put the link to where you can download Vulkan in the description. I will be selecting Windows, and then over here we need the SDK installer. So I'll be downloading this, save the file. Now, once it is finished downloading, we will start the installer, and I'll go through the installation process. Don't worry about this deprecation notice, just press next. This is where Vulkan will be installed. I choose the default location. There's some optional stuff. I will not be using any of those, but I think they're very interesting and I want to use them in the future. But for now, I will not be using them. And then we acknowledge the license and it's fine. We install. Again, we ignore the notice and we continue. Now, if we want to check if Vulkan is installed, we can open the command line and type in echo %Vulkan SDK %. We will need this path later. We can also check if Vulkan is successfully running on our system. To do that, we locate Vulkan. It is under C, Vulkan SDK, if we didn't change the default location. And then you have the version here. You go in here, you go into bin, and one of these exes is vkcube.exe. We open that and we should be seeing a spinning cube. Back in VS Code, we have to close the application now because we just installed Vulkan and VS Code doesn't know about Vulkan yet. So we have to close it and then open it again. Once you've successfully restarted VS Code, we can start by including Vulkan. To include something, we type /I. I forgot earlier, but we need to include the source folder. Include works by specifying folder names. Then we include Vulkan. And how we do that is we specify the name earlier, Vulkan SDK in %, and then we type /include. Let me show you what that is. Under C in Vulkan, the Vulkan SDK environment variable points to this folder, but we need to include the source code, which is under include. So we have to do the /include. Next thing we need is the lib from Vulkan, which is under lib. And what we want to link against is the vulkan-1.lib file. And we can do that by specifying -link. How this works is the CL compiler will look in specific paths, and we have to add the Vulkan path to these. So the CL compiler knows where to look. We have to specify a lib path. And that lib path will be, again, Vulkan SDK %/lib. And this is where it will find the vulkan-1.lib file. And that's it. This is now we have successfully included and linked against Vulkan using the CL compiler. Next, we can add some defines. You can add defines by typing /d. And I like to add debug most of the time in the beginning. And we might add some other stuff later, but this is what we do for now. Let's do something more interesting than just doing IO. We will include Vulkan /vulkan.h. In case VsCode doesn't find Vulkan for you, what you can do is you can press Ctrl-Shift-P, which will bring up this window, and then you type in preferences and then JSON, which will open the settings.json file. And in the settings.json file down here, I will put this link in the description as well. You can add default include path. For example, I have added the source folder, which I think is default, and I've also added the Vulkan SDK include. Notice though that there is no percentage signs in front of these, but it is in curly braces. That is the difference, and that is very important. You should be able to include Vulkan header then. The next thing we'll do is create a very simple Vulkan instance and see if it actually works. So we type in vk create instance over here. That's how I like to do it. And then we look at the stuff that we need. In order to create this vk instance, we need a vk instance create info. Okay, so we go up here, we type in vk instance create info. Boom. Call this instance info. And I like to initialize it to 0 using C++'s initializing. Now once we have the instance create info, we can press F12 or Control click to go to the definition and see what it actually wants us to specify. We need a so-called structure type. We need a pnext. We need flags, application info, layer count, enabled layers, extension count, enabled extension. Actually, we don't need most of these. The most important thing that we need for now is the s-type. So we type in instance info.s-type. And this is what will happen with every structure that you define in Vulkan. Most of the time, you will type in vk structure type instance create info. Oftentimes, the name after structure type references the name of the structure. Instance create info. Over here, instance create info. Looking at the structure again, the next thing we need is the vk application info. So we go back and specify the vk application info. App info. And we initialize that one to 0 as well. Then we type in app info dot and see what we need. Well, we need an API version, application version, engine version, application name, engine name, and an s-type. The s-type is important. We add in vk structure type application info. This is what you always have to specify. After that, we go app info and check if we need anything else. We can specify these things if we want to. Let's call this application name Pong and app info. Engine name, call that Pong Jin or Pong Engine, right? And since I'm unsure if we actually need everything, I'll just specify these and test it out if it actually works. And this is what I want to emphasize. In my opinion, the best way to learn stuff is by just trying out and exploring your options. You will fail and do a bunch of dumb mistakes, but in the end, in my opinion, this is the best way to learn because you will then know what not to do. Instance info dot pointer application info. Oftentimes in Vulkan, you will see this P in front of the actual name that you need to specify. And this signals you that you need a pointer. So we will do the pointer to app info. We can just check instance info real quick if we need anything else. We are not using any layers and we are not using any extensions yet, so we don't need any of them. And then we pass into the vk create instance the instance create info, instance info. The next thing is a allocation callback allocator. I will not be using them and I will always be specifying this as 0. If you want to read up on that, I highly suggest you read up in the Vulkan specification on how to use them, or Google. But I don't want to waste my time with them if I don't need them. I've not been needing them yet. The next thing is the vk instance. We don't have a vk instance yet, which is the actual object that will be created when we call the vk create instance call. So, but I'm just gonna create this on the stack right here, vk instance. Instance, right? Oops. And we pass that in probably by pointer, if it actually works. Yeah, so we pass in the p instance, pointer to the instance. Most of the Vulkan calls will return a what is called VK result return value. We can then check against the VK result by doing if result is the same as VK success, which is a defined success variable for Vulkan. We can then go ahead and do std cout successfully created Vulkan instance. std end line. And by the way, I included the IO stream back in here. Small disclaimer, I was looking for the problem. I set the variable name to includes instead of includes, which means it wouldn't find Vulkan. We should now be able to press Ctrl+Shift+B to compile our program, which it does, and then press F5 to run the program. Down here in the debug console, we should see successfully created Vulkan instance, if I can spell. And we created an instance. And now the next time we can go ahead and build a platform layer before we go and write the renderer. This will give us a basic playing ground in order to continue further. I'm trying to program and explain at the same time, but I think it might be too slow. If you'd be so kind and let me know down in the comments, I'd appreciate it. Thank you all for watching and see you next time.